Today, I'd like to discuss modeling missing data, robust data access with Kentico Xperience. Hello, my name is Sean G. Wright. I'm a Chief Solutions Architect at Wired Views. I'm a Kentico Xperience MVP and community enthusiast, and I'm co-founder of Craft Brewing Business. So it's easy to get wrapped up in technical solutions to all of our content management problems. But first, I'd like to say that we need to do content modeling first and then code modeling second. We need to make sure that we're modeling the right thing. And content modeling helps engineers think like content managers. So there's really benefits to be had in making sure that we put the right thing first and then address solutions to any problems that we might encounter. So first, let's consider optional content. And when we're talking about optional content, what we're really talking about is modeling the complexity of flexible content management. So why might we have optional content in our sites? Optional content might improve the content management experience. We might be modeling information within an organization, which is inherently optional. Or we might have requirements for more flexible presentation. Sometimes this is required by design variations. So let's look at the Dancing Goat Cafe page type. So this has a lot of text fields. All are required except for the additional notes field. And we have this featured coffee. And if we were to generate the code for this page type, Xperience would generate code that has default values when nothing is selected for the featured coffee. And it wouldn't use Null or any other language features like that. So we have a photo that's optional and a featured coffee that's optional. So if we look at a model in C# to model that page type, this is something that we might come up with. So we have a top level model type, which is the cafe view model, and it has multiple optional properties. This would represent the optional content in the page type, like the photo, the note, and the featured coffee. And then each of these potentially has additional optional properties of its own. So in the case of the featured coffee view model, the coffee page type in the Dancing Goat site has an optional image, and the image view model has optional alt text. So when we have structured content, what we usually end up with is C#, custom C# types to model that structured content. When we have complex structured content, we end up with complex C# types. If the content isn't supplied for the page type, what would the value be for each one of these things? It's something we need to consider. For example, the linked page or the image. So here's some solutions to modeling optional content. We can use classic C# implicit nulls. This is dangerous. I'm going to advise that you stay away from this option. We could use C# nullable reference types. This is a good option. We'll consider the pros and cons of this. We could also try the null object pattern. This is another option. And then finally, the best option in my opinion is the maybe monad. So this ranking is my personal opinion. I've tried out these various options in different applications. I found the maybe monad to be the best option, but they each have their pros and cons, and you should try them out and see what works for your project or your team. However, always avoid implicit nulls in C# if possible. So the nullable reference types, or the pros. It's built into the language. We can just annotate existing code to turn this on. We don't need extra libraries or extra types in C# to make this work. And this enforces checks that we should already be making in our code. However, the cons, we will have lots of procedural guard checks. There's no domain meaning to null in C# when it comes to our specific application or site. It's not compatible with .NET Standard 2.0, which means we can't use it in the administration application. And there's little benefit to using nullable reference types if we don't enable compiler errors. And in that case, we need to go and fix all those errors. You can see here that we have errors for contact URL, name, and that's because we've stated that they're non-nullable, but we haven't given them default values. So how might we solve this problem? Well, we could use C# record types and explicit constructors. And this would make sure that everything that needs a value is supplied at the time that this type is created. Now, this nullable reference types might not solve our optional data, optional content problem, but we should always enable them in our ASP.NET Core applications. There's a huge benefit to having them turned on, even if we're just using them as a language feature. So let's consider the null object pattern. What are the pros? Well, there's a lot of pros, similar to what we mentioned for the null reference types, but there's also fewer procedural checks because with null object pattern, you always have a value. You don't have this case where sometimes you have a value and sometimes you don't. So we can just use those values and we don't have to have as many checks in our code. Cons? Well, every C# type that we want to follow the null object pattern, it needs a null object and it needs a way to check to see if it's a null instance. It adds complexity to the type definitions, and we can see that here. There's lots of additional code noise in our types that are just supposed to be modeling our content type. The null object pattern also doesn't solve built-in types like string, because we can't create a null object instance of a string. So here you can see that the featured coffee view model has a empty instance, which can also use the empty image view model as its instance. So these things compose well together. However, we end up in this situation where we have null reference types for the built-in C# types, and then we have the null object pattern for our custom types. This can be problematic because now we're coming up with two solutions to solve what should be the same problem. And it can be difficult to maintain consistency of this approach across the project and a team. So let's now consider the maybe monad. Pros. It moves the representation of optional out of our C# type. So our view models become much simpler. They're much easier to read. There's no procedural checks that we'll be doing in our code until we get to rendering in the Razor views. And the maybe type clearly represents 0 or 1. This thing is here or it's not. The cons? Well, a monad is functional programming terminology, and that can be intimidating to a lot of developers. And also, maybe as a monad tends to infect an application in the same way that async await or task and collections do. If you start using a collection or a list in one part of your application, that typically bubbles up through the whole application to the point where you're either returning that data or rendering it. So the benefits of the maybe monad tend to increase as we increase the number of layers, mappings, transformations, data and presentation requirements, business logic in the application. If you have a small app, you might not see as many benefits and it might seem like overhead. But if you have a larger enterprise Kentico Xperience application, I found you can get a lot of benefits from using the maybe monad. So now let's cover missing data. So we want to make sure we have graceful and intelligent handling of what should be there, but isn't. So what is missing data? Well, first I'll say what missing data is not. It's not optional content. Optional content is intentionally not there. The content manager chose to not have a featured coffee for a cafe. But missing data is unexpected. We thought, based on the logic in the code, that something should be there. A content manager thought something should be there, but it ended up not being there. So here's a question. Do we model these unexpected cases in code, or do we only consider the happy path? If we fail to model that missing data and a page or the functionality of a page breaks, who's impacted? Visitors are going to be impacted. Content managers are going to be impacted. Marketers, site administrators, web developers, really anyone using the site is going to be impacted if we fail to account for these situations. The web developer case should probably hit home to you that if you are someone that is developing a site, because you're going to be called in to fix the regression, and it might be hard to identify what the problem is if we haven't handled this situation correctly or handled it in a helpful way. So let's look at the Dancing Goat Cafe again. We have some linked content, this featured coffee. So what happens if the featured coffee page that we're linking to is accidentally deleted. The GUID value is still going to be in the page type field, but it's not going to point to anything. How do we alert administrators, content managers to the fact that hey, there's a break here? There's something missing that should be there. So let's consider some solutions to modeling this missing data. We could use C# exceptions with try and catch. However, I think this is dangerous, similar to using implicit nulls in C#. We don't want to use exceptions to control application or logic flow. Method signatures in C# are a contract between the caller and the method. Exceptions are not part of that method signature. They're not part of that contract. They're hidden. So if you throw an exception from a method, there's no way for the caller to know, based on looking at that method signature, that that's going to happen. Exceptions should be used for exceptional cases, not for controlling logic or flow. And this is why exceptions are poor at modeling this missing data. We could use C# tuples to return nullable error and nullable data. This is better. And here's an example of what that might look like. We would have a method get coffee. We pass in that node GUID, and then we return back a string and a coffee tuple. If it failed to get that coffee, then the error would be populated. And if it failed to get the coffee, or if it failed, there was no error and there was a success, we would return the coffee instead. This is slightly problematic because now we still have to do these checks, and there's nothing that really ties the existence of the coffee to the non-existence of the error. We just kind of have to trust that the application was coded correctly, that the internals of that method work how we expect. So then there's a third option, which is the result monad. And in my opinion, this is the best. Again, these are personal opinions. Try out these options if you're not familiar with them. See what works best for your project. But try to avoid exceptions to model missing data or controlling application flow. So let's look at rendering that cafe page type that we originally had. So first, we start out guarding for values. So this is something that we'd be doing anyway if we had nullable reference types in null object pattern. We only want to render something if we know it's there. In the case of using the maybe monad, we're going to say cafe.photo.hasValue. And if the value is there, we're going to get that value and we're going to render it out. That monad allows us to supply default values. So if the alt text is not supplied, we can populate it with something else. And then we're going to separate operations where the content could be missing. So we know that the coffee, the featured coffee of our cafe, might not be there. We're going to break that operation out into its own view component, its own slice of functionality, and handle that situation where there could be a problem in an isolated way. So just consider that we're starting to use these monads here, but the rendering code is going to look a lot like how it would for the other options that we had. This looks like a typical Razor view. Okay, so let's look at that coffee, that featured coffee that we're trying to retrieve from the database. How might we model that? How might we write the code when we're using the result type? Well, it's going to be in the method signature, which is great. It becomes very clear what this method is returning. Then we're going to check to see if that node GUID is the default. If it is, then we're going to know that this is a situation where the default value that Kentico Xperience is returning for this field is what is being supplied, and we're going to treat that as optional data, an optional featured coffee that was not selected. Then we try to query for that. If we found a value, we're going to return a success. It's a maybe with a value. The result ends up being in the success state. If there was none, then we're going to return a failure. And we're going to include a helpful error message trying to explain exactly what happened here. So we could use the maybe type without the result, but we really want to represent optional content and missing data separately. So we use two different types to model them. So now let's look at how we build up our featured coffee view model. And this is going to be in our view component. So the first thing is that we now have a coffee repository that returns a result type instead of null or something else. We add a custom view extension to our application so that we can keep this fluent pattern. With monads like task, or especially with IEnumerable, and you're going to be familiar with using link operations, you end up with this fluent pattern of chaining methods. So we want to stay in that mindset. We want to stay in that code pattern. And so you can author custom extensions to stay in that world of using the monad and make it convenient for developers. And you can see here, down here at the bottom, this metafile repository, this is going to return a result for get metafile because the image for our featured coffee might not be there. However, we want to turn that into a maybe. So we're still able to choose the right tool for the job when we're doing our modeling. And this match method lets us convert from the result type to a maybe type. With these monads, you'll find that it's very easy to go back and forth between them. Okay, what about when we want to render this coffee? How are we going to do that? Well, we're still going to have those procedural checks at the point of rendering. And this would be the case if we were using nulls or the null object pattern or something else. We still want to check and make sure the thing is there before we render it. In this case, we are going to show the error to content managers when they're in the page builder. So we have these helpful error messages that show, hey, something's missing. And the content manager will see that if they're viewing the page in the page builder, and they can either take that problem to a developer or they might be able to resolve that themselves. And then we progressively show content when it's available, which means we don't fail rendering the entire thing if something's not there. Instead, we show what we can. We get to decide when we have this additional information about the missing data or the optional data, how we want to present that information. So, do we handle this missing data? It seems like we've just jumped through a bunch of hoops in order to make sure that we can show an error message on the page. We have to make a decision about it when we're architecting a site. It's going to happen. It must be handled somehow. So we have one option, which is to catch and ignore. I've seen this in a lot of applications. Sometimes it works. There might not be that many errors in the application. It might not be that complex. But typically, I think we're going to want to capture, model, and present this information. And we're going to want to present it contextually. So, we have a bunch of steps that we've had to go through here to present these errors. We could make an improvement here. We could create a reusable error view. We could pass the error to the error view on a failure. We could pass the view model to the normal view that we want to render on success. And that would get rid of that result T type in our view. There's ways that we can improve this developer experience, but first we're making the decision that we want to handle these failure cases and present this information. Again, consider what impact do your architectural choices have on visitors and stakeholders? What about on ourselves when we're diagnosing regressions? So here's some tips on modeling missing data. We want to encapsulate error handling within services. So Kentico Xperience types like iPageRetriever and iInfoProvider, they're going to return nulls. You might want to consider wrapping those types and converting the null into a result or into a maybe. We want to return successful or failed results from our methods. And it's kind of cool that we can combine that with the maybe type. So we could have a result of maybe of coffee. What does this actually mean? Because this might look confusing to you if you're not familiar with what these types do. Well, it really means it's the result of querying for optional content, which might have succeeded or failed. And then finally, we're going to want to decompose rendering and view models along error boundaries. So don't try to put everything all into one view, everything all into one big view model. Instead, identify the places where you could have missing data, where you might have optional content, and decompose and structure your code accordingly. So we can use isolated view components to contain the failures, display errors in the page builder to content managers, and then hide them or use placeholders on the live site. So here's some references. If you're interested in taking this approach in your application, here's a C# monad library I use commonly. It's a great library. It's very intuitive to use. There's great documentation for it. Here's a TypeScript variation. If you are doing front-end development in your Kentico Xperience applications and you're using TypeScript, you can follow the same patterns. And then below that is a link to a video where I talk about the maybe monad in particular in depth and using it with Kentico Xperience. You can also check out more information on this by reading my blog. I did a 3-part series about using the maybe monad. Thanks.